Hello there and welcome. I am so glad you are here with me today. Before we begin our journey into the mysteries of the cosmos, I want you to take a moment just for yourself. Wherever you are right now, whether you are sitting in a chair, lying on a bed, or walking outside, just pause, take a deep breath in, and let it out slowly. Let go of the stress of your day. Let go of the noise of the city, the notifications on your phone, and the endless rush of modern life. Now I want you to use your imagination. Close your eyes if you can. Imagine you are lifting off from the ground. You are rising higher and higher past the clouds, past the blue sky until you leave the earth behind. You are now floating in the deepest, darkest ocean imaginable. You are drifting in space. Here there is no sound. There is no wind. There is only absolute heavy silence. It is a silence so deep that you can almost hear the beat of your own heart. Around you there are billions of stars shining like diamonds on black velvet. Some are burning bright. Some are dying. Between them lie vast distances that the human mind can barely comprehend. In this infinite black ocean, our planet Earth is just a tiny, fragile blue dot. And for as long as humans have looked up at those stars, we have asked one single terrifying question: is anybody out there? Or are we completely alone in this endless dark? Tonight we are going to travel back in time to a moment when we thought we finally had an answer. A moment when the universe for the very first time seemed to speak back to us. Let's travel back to the year 1977. The world was a very different place. There was no internet, no smartphones, and no social media. It was a time of disco music. Star Wars had just arrived in theaters, and people were dreaming about the future of space travel. Our destination is a quiet, rural field in Delaware, Ohio. It is a warm night in the middle of August. The air is filled with the sound of crickets and the humidity of summer. In this field there sat a strange, massive structure. It didn't look like the round satellite dishes you see in movies. It looked more like a giant metal mesh stretched across the ground like a football stadium. This was the Big Ear radio telescope. It was a peaceful place. The Big Ear was not a machine that looked, it was a machine that listened. While the world slept, the Big Ear was working. It relied on the rotation of the Earth to scan the sky. As our planet turned, the telescope swept across the heavens, collecting radio waves from the stars, searching for anything unusual. Inside a small, cluttered control room nearby, computers were humming. But these were not the sleek laptops we have today. These were old, bulky mainframes that printed out data on long sheets of paper. The machine would print row after row of numbers and letters representing the intensity of the radio waves hitting the telescope. Usually the machine printed low numbers like 1, 2, or 3. This was just background noise, the natural static of the universe. It was the sound of stars being born or gas clouds drifting. Nothing special, just the quiet hum of space. But on the night of August 15th, leading into the morning of August 16th, something changed. A volunteer astronomer named Jerry Amon was reviewing the data a few days later. He was sitting at a desk, drinking coffee, flipping through the stacks of paper printouts. It was a routine task, something he'd done 1,000 times before. His eyes scanned down the columns of numbers. 1, 1, 2, 1. And then his eyes stopped. Suddenly, in the middle of the page, the numbers spiked. They shot up. The intensity of the signal grew stronger and stronger incredibly fast. The computer used numbers for low signals, but when the signal got too strong for numbers, it switched to letters. On the paper, the sequence read 6, E, Q, U, J, 5. Jerry Amon froze. His heart began to race. This was not background noise. This was not a plane or a satellite or a reflection. This was a loud, clear, and powerful scream coming from the constellation Sagittarius. It was incredibly narrow and focused. In the world of astronomy, we call this a narrowband signal. Nature, like stars or galaxies, usually creates wide noise like a messy splash of water, but this signal was sharp like a laser beam pointing directly at Earth. Even more shocking was the frequency. The signal was vibrating at exactly 1,420 megahertz. Now, why is that number important? To astronomers, 1,420 megahertz is a magic number. It is the frequency of hydrogen. Hydrogen is the most common element in the universe. It is the basic building block of everything. If there is an intelligent civilization out there, and they want to talk to other intelligent life forms, scientists have always believed they would use this frequency. It is considered the universal waterhole. It is a meeting place on the radio dial. It is like a universal channel that everyone in the galaxy would agree to listen to. So when Jerry saw that the signal was exactly at this hydrogen frequency, he knew this was huge. It was like walking through a dark, silent forest and suddenly hearing someone whistle a perfect, clear note. Overcome with excitement, Jerry grabbed a red pen from his desk. He drew a big, thick circle around the code 6EQJ5, and right next to it in the margin of the paper, he wrote one single word in excited cursive script: "Wow!" That is how the wow signal got its name. It was the raw human reaction to a cosmic mystery. The signal was strong. It was 30 times louder than the normal background noise of deep space. But here is the heartbreaking part of the story. The signal lasted for exactly 72 seconds. It wasn't that the aliens stopped talking after 72 seconds. It was because of the Big Ear telescope itself. Remember, the telescope could not move. It was fixed to the ground. It relied on the Earth's rotation to scan the sky. Based on the speed of the Earth turning, the telescope could only focus on any single point in the sky for exactly 72 seconds. The signal appeared, grew to a peak, and then faded away as the Earth turned its ear away from that spot in the darkness. Jerry and the other astronomers were ecstatic. They had been waiting for this moment for years. They quickly prepared the telescope to listen again. They waited for the Earth to rotate back to the same spot the next day. They were ready to record the message, to decode it, to maybe even say hello back. They listened the next night. Silence. They listened the night after that. Nothing but static. They pointed more powerful telescopes at that spot in Sagittarius. They scanned the area for weeks, then months, then years. The signal was gone. It has been 48 years since that summer night in Ohio, nearly half a century. In all that time, with all our advanced technology, with our supercomputers and giant satellite dishes, we have never heard a sound like that again. The wow signal remains the strongest candidate we have ever had for a message from an extraterrestrial civilization. It was perfect. It was on the right frequency. It came from deep space. It was loud. But it was a ghost. Imagine receiving a phone call in the middle of the night. You pick up and you hear a voice say, "I am here," and then the line goes dead. You call back, but the number doesn't exist. You wait by the phone for 50 years, but it never rings again. That is the feeling of the wow signal. It left us with a profound sense of loneliness. For 72 seconds, the universe felt crowded like a room full of friends. But when the signal vanished, the silence that followed felt heavier than before. Was it a mistake? Was it a secret military satellite? Or was it really a greeting from a civilization that died out millions of years ago? Their final message drifting through the dark until it hit a metal mesh in Ohio. We still do not know. The mystery remains. We are still here on our pale blue dot, drifting in the quiet ocean, listening to the static, waiting for the phone to ring one more time. The Interstellar Traveller. Fast forward to the year 2025. The world has changed significantly since Jerry Amon circled 6EQUJ5 on a computer printout, but the mystery of that night remains as potent as ever. For decades, astronomers looked for a planet or a star that could have sent the signal, but they found nothing but silence. They were looking for a permanent resident of the galaxy, a house on a street. They never thought to look for a traveller passing through. This brings us to the entrance of Professor Avi Loeb, a renowned figure from Harvard University known for his open-mindedness toward extraterrestrial life. Loeb brought a fresh perspective to the old data. He did not look for a star, he looked for a visitor. His calculations introduced the world to a new candidate, an entity known as 3I Atlas. The concept of an interstellar object is fascinating and somewhat terrifying, unlike the asteroids and comets that were born in our own solar system. The leftover bricks from the construction of our sun and planets and interstellar object is a stranger. It was born around a different star, perhaps billions of miles away. Sometime in the ancient past, it was kicked out of its home system, ejected by the gravity of a giant planet or the explosion of its parent star. The lonely journey of 3I Atlas. To understand the significance of 3I Atlas, we must use our imagination to visualize its history. This is not just a rock, it is a time capsule. Imagine an object drifting through the deepest voids of space for billions of years. It is a silent voyage. For eons, it travels through the total darkness between stars where the temperature is just above absolute zero. It glides past colourful nebulas where new stars are being born, but it does not stop. It drifts past the graveyards of dead stars, witnessing the quiet aftermath of supernovas. It is completely alone, a tiny speck of matter moving through the infinite black ocean of the universe. It has no engine, no pilot, and no destination. It simply obeys the laws of physics, coasting on the momentum from a push it received before Earth even had dinosaurs. It is a ghost from another world. And then after all that time, its path just happened to intersect with our neighbourhood. The geometry of 1977. This is where the story connects back to that famous night in Ohio. Professor Loeb's calculations revealed something startling about the position of 3I Atlas. Space is vast and distances are hard to comprehend. To make it simple, astronomers use a unit called an astronomical unit, or AU. 1 AU is the distance from the Earth to the Sun. It is our standard yardstick. Jupiter is about 5 AU away, Pluto's about 40 AU away. According to the new calculations back on August 15, 1977, 3I Atlas was passing through our solar system's backyard. It was approximately 600 astronomical units away from the Sun. To put that in perspective, 600 AU is incredibly far away. It is far beyond Pluto in the dark, icy fringes of our system, but in cosmic terms, it is right next door. But the distance is not the most important part. The most important part is the alignment. Imagine drawing a straight line on a piece of paper. At one end of the line, you put the Earth. If you extend that line out into space on that specific night in 1977, that line passes directly through the location of 3I Atlas. And if you keep drawing that line further billions of miles into the background, it points directly to the constellation of Sagittarius. Sagittarius is a very busy part of the sky. It is the direction of the centre of our Milky Way galaxy. It is full of stars, radiation and noise. The wow signal came from that direction. This creates a perfect geometric connection. The Earth. The interstellar object 3I Atlas and the source of the signal were all perfectly lined up. The mirror in the dark. Why does this alignment matter? Think of a mirror flashing in the sun. If you are standing in a dark field and someone miles away flashes a mirror at you, you see a sudden bright burst of light. The person holding the mirror didn't create the light, they just reflected it. Professor Loeb suggests a similar possibility. What if the wow signal was not a direct transmission sent to us? What if it was a powerful radio beam sweeping across the galaxy much like a lighthouse beam? When that beam hit 3I Atlas, the object might have acted like a natural mirror. It could have reflected that radio energy toward Earth for just a brief moment. Or perhaps, as some more daring theories suggest, the object was not a natural rock at all, but an artificial probe that was activated when it received the beam. However, even if we stick to the simplest explanation, a natural reflection, the geometry is undeniable. A 0.6% probability. When we look at the universe, scientists often ask, was this just an accident? Professor Loeb calculated the odds of this happening by random chance. What are the chances that a large interstellar object would be in that exact spot at that exact time, perfectly aligned with the Earth and the Sagittarius constellation? The calculation shows a probability of about 0.6%. That is less than 1%. In the world of statistics, a number that's small forces us to pause. It suggests that this was an incredibly rare event. If 3I Atlas had arrived a few months later or a few months earlier, it would not have been in line. If the Earth had been on the other side of the Sun, we would have missed it. This low probability brings up a feeling of destiny. It makes us wonder about the clockwork of the universe. Out of all the billions of years that the universe has existed, and out of all the infinite directions an object could travel, this one traveller arrived at the precise moment to create a mystery that would haunt humanity for half a century. It feels like a cosmic appointment that we were lucky enough to keep. The meaning of the coincidence. The story of 3I Atlas changes how we view the wow signal. It shifts our focus from a distant intelligent civilization trying to call us on the phone to a complex interaction of celestial mechanics. It reminds us that the universe is dynamic, it is not a static painting. Things are moving, flying, spinning and crossing paths constantly. 3I Atlas was a visitor that passed through our lives like a stranger in the night. It may have held the answer to the signal, but by the time we realized it was there, it was already gone, heading back out into the deep darkness, never to return. This revelation connects the past of 1977 with the science of 2025. It tells us that the answers to our greatest mysteries might not be found by looking for new data, but by looking at the old data with new eyes. The messenger was there all along, hiding in the dark, 600 times further from the Sun than we are silently carrying the secret of the signal. To understand the strangeness of 3I Atlas, we must first close our eyes and reimagine the neighbourhood we live in. When we think of the solar system, we often picture a chaotic swarm of bees with planets buzzing around the Sun in all directions. But that is not quite right. Our cosmic home is actually very organised. It is remarkably flat. Imagine a fresh pizza dough being spun in the air by a chef. As it spins faster and faster, it flattens out into a perfect thin disk. This is exactly what happened when our solar system was born. Because of this spinning history, almost everything of importance, Mercury, Venus, Earth, Mars, Jupiter and the rest, lives on this flat dinner plate. And just as importantly, they all move in the exact same direction. If you were to look down from high above the Sun's North Pole, you would see a giant cosmic racetrack. Every planet, every major moon and almost every asteroid is driving counterclockwise. It is a one-way highway with strict traffic laws that have been obeyed for 4 billion years. This is the harmonious flow of our history. It is the standard rhythm of the dance. Then there is 3i Atlas. If the solar system is a busy highway, where millions of cars are driving west, 3i Atlas is the one silent silver car driving east. In the language of astronomers, this is called a retrograde orbit. It is moving backwards against the flow of traffic. Usually when astronomers find an object moving backwards like this, it is a wild, chaotic visitor from the very edge of the system, a comet falling in from the top or the bottom, diving through the disk at a steep, sharp angle. These visitors usually look like they are falling from the ceiling to the floor. But 3i Atlas is confusing because it is not behaving like a chaotic falling rock, it is behaving like a planet that simply forgot which way to turn. It does not dive from the top, it stays almost perfectly flat on the dinner plate. Its path is tilted only 5 degrees relative to the Earth and the other planets. 5 degrees is a tiny number. To visualize this, imagine holding a sheet of paper flat on a table. Now lift just one corner of the paper up by less than an inch. That subtle slope is the only difference between the plane of 3i Atlas and the plane of Earth. It is incredibly precise. It implies that this object is not just a random visitor crashing through. It suggests that 3i Atlas has settled in. It has found a stable, smooth lane on the highway, but it is stubbornly driving in the wrong direction. This combination, moving backwards retrograde while staying flat low inclination, is rare. It creates a terrifyingly beautiful scenario. Because it is moving against the grain, its relative speed, when it passes other planets, is enormous. It is not merging with traffic, it is speeding head-on toward it. This brings us to the most breathtaking part of the dance, the timing. The path of 3i Atlas is not a lonely road. Because it stays on the flat disk, its path intersects with the orbits of the major planets. It is a thread being woven through a spinning needle. First, consider the giant Jupiter. In most cosmic stories, Jupiter is the bully. Its gravity is so massive that it usually chews up small comets or throws them out into the darkness. For a small object to cross Jupiter's path and survive requires luck, but 3i Atlas does not just rely on luck, it relies on perfect placement. It slips past the giant. It uses the gravity of the planets not as a trap but as a pivot point. Then there is the relationship with Mars and Venus. The orbit of 3i Atlas is shaped in such a way that it dives deep into the inner solar system. As it travels, it must cross the lanes of these planets. If 3i Atlas were just a few days early or a few days late, the gravitational tug from Mars could destabilize it, ruining that perfect 5-degree tilt. If it were too slow, Venus might pull it off course, but the numbers suggest a choreography that is hard to believe. It feels less like a random rock tumbling through space and more like a train arriving at a station, exactly when the schedule says it should. Imagine standing on the surface of 3i Atlas as it makes its journey. You're moving backwards through the dark. You see Mars approaching not as a slow wandering star, but rushing past at incredible speed, because you're flying head-on towards each other. You miss the collision, but you feel the wind of its gravity. You glide past untouched. Then comes Venus, the bright hot sentinel. Again, the timing is impeccable. You slip through the gap in traffic exactly when the road is clear. This is what makes the dance so mesmerizing to those who study the numbers. It brings up a feeling of ancient precision. When we look at a comet or an asteroid, we usually think of rocks tumbling blindly. But when we look at the orbit of 3i Atlas, we get a different feeling. We get the sensation of a clock. A clock is a machine of gears and springs. When the minute hand crosses the hour hand, it does not crash, it is designed to pass. 3i Atlas moves with that same mechanical elegance. It feels as though this trajectory was wound up millions of years ago. It feels as though the universe set a timer waiting for the exact moment when Mars would be here, Venus would be there, and Jupiter would be over there so that 3i Atlas could thread the needle without crashing. It's a high-speed ballet performed on a stage billions of miles wide. The dancer is moving the wrong way, yet somehow it never steps on anyone's toes. It respects the lane, keeping its 5-degree tilt with discipline, silent and fast. In the vast emptiness of space, physics is the only rule. There is no pilot steering this object. There is no computer making corrections. There is only momentum and gravity. And yet when we plot the lines on a computer's screen, seeing that retrograde loop weave through the planets, it is hard not to feel a sense of wonder. It reminds us that the solar system is not just a collection of rocks, it is a dynamic moving system, where even the anomalies, the things that go backwards, have their own perfect rhythmic place in the design. To understand what this visitor is truly made of, we must look beyond its shape and movement. We have to look at its skin and its blood. We must become cosmic alchemists, breaking down the light reflecting off its surface to understand the ingredients of this recipe. When we do this, the story changes from a tale of a strange rock to a mystery of impossible chemistry. When our telescopes first caught a glimpse of this object, it appeared deep red. In the language of astronomy, red is usually the colour of age. It tells us that an object has been wandering the dark, cold hallways of space for millions of years, constantly bombarded by cosmic radiation. This radiation cooks the surface, turning organic, carbon-rich dust into a thick, reddish tar. It is the cosmic equivalent of a sunburn that has lasted for an eternity. Scientists expected this. It is the standard uniform for any comet or asteroid that lives in the outer edges of a solar system. But as the object tumbled closer to the sun, something unexpected happened. The heat began to peel back that ancient sunburned layer. Underneath the dark red crust, the instruments picked up a shifting colour, a spectral signature that hinted at a vibrant, almost electric green. In nature, colours are clues. Red is usually rust or organic tar, blue is often ice, but green. On Earth, green means life, grass and leaves. In space, however, a green glow usually signals the presence of specific gases or metals reacting to sunlight. It suggests that the red rock was merely a costume. The object was shedding its disguise, revealing a surface that looked less like a dusty stone and more like a fresh, unblemished material that had been protected for a long journey. This brings us to the most baffling discovery of all the metal composition. If you were to go out into the desert and find a meteorite, or if you looked at the vast majority of asteroids floating in our solar system, you would find a very specific family of metals. Nature loves to pair iron and nickel together. They are the siblings of the cosmos. They form together in the hearts of dying stars and clump together to build the cores of planets. Finding a space rock made of iron and nickel is like finding salt water in the ocean. It is exactly what you expect. Shutterstock. But this object broke the family apart. The data suggested a surface rich in nickel but strangely suspiciously empty of iron. To understand why this is so disturbing to a scientist, imagine walking through a wild, uninhabited forest. You expect to find wood leaves, stones and dirt, but then you stumble upon a block of pure, shiny aluminum. Nature does not create blocks of pure aluminum. Nature mixes things. Nature is messy. To get pure metal, you need a refinery, you need a furnace, you need intention. Iron is one of the most abundant heavy elements in the universe. For an object to be heavy in nickel but lacking in iron is almost chemically impossible in a natural formation scenario. It is like baking a cake with flour and sugar, but somehow the flour disappears during the baking process, leaving only the sugar structure behind. This anomaly forces us to look at the object not as a geological accident, but perhaps as an alloy. In our own human industry, we use superalloys, mixtures of metals designed for specific jobs. We use high nickel alloys when we need a material that can survive extreme heat without melting or warping like in the engines of jet fighters or the casings of deep-sea submarines. If you were sending a probe across the galaxy knowing it would have to dive close to burning stars and survive the freezing void between them, you would not build it out of common rock. You would build it out of something that could take the punishment. You would build it out of a nickel superalloy. The chemistry here looks less like a random clump of space dust and more like a heat shield. Then there is the matter of its breath. Comets are defined by what they exhale. As they get close to the sun, the ice on their surface turns instantly into gas, creating the beautiful tail we see in the night sky. This gas acts like a rocket thruster, pushing the comet and changing its speed. We saw this object speed up, so we assumed it was outgassing just like a normal comet. But when we looked for the gas, the mystery deepened. A standard comet is a dirty snowball. It releases mostly water vapor, H2O. It is the most common solvent in the universe. But when astronomers pointed their sensors at this object to sniff out the water, they found nothing. It was dry. Instead, the limited data pointed toward a massive spike in carbon dioxide. The ratio was completely inverted. While a normal comet might be mostly water with a little bit of carbon dioxide, this object appeared to be venting 95% carbon dioxide. Why does this matter? Because carbon dioxide is a heavy gas. It is dense. In the natural formation of comets, water and carbon dioxide freeze together. To have a body that releases almost exclusively carbon dioxide suggests that the water was either stripped away entirely or it was never there to begin with. Think of it like a car engine versus a boiling kettle. A kettle releases steam water vapor. A car releases exhaust carbon dioxide. Finding a rock that accelerates without a visible tail while pumping out pure carbon dioxide feels less like a melting iceberg and more like an engine dumping its waste product. Furthermore, the way this gas was released was invisible to our eyes. Usually dust gets dragged along with the gas reflecting sunlight and making the tail visible. Here there was no dust, just pure invisible gas. This implies a level of refinement and purity that again is rarely seen in the messy, chaotic workshop of nature. So where does this leave us? We have an object that changes colour from the distinct red of cosmic age to a vibrant, fresh green. We have a metallic composition that mimics high-grade, heat-resistant industrial alloys lacking the iron that nature always provides. And we have a propulsion system, a venting of gas that lacks the signature water of natural comets and instead breathes out a pure stream of heavy carbon dioxide. We are left staring at a set of ingredients that do not belong in the same bowl. A rock should not be this pure. A comet should not be this dry. We must ask ourselves a gentle but haunting question: if nature did not mix these chemicals, who did? Are we looking at a freak accident of planetary formation? A 1 in a trillion stone that just happened to lose all its iron and water? Or are we looking at a manufactured casing? Is this chemistry the result of billions of years of random collisions? Or is it the specific formula for a vessel built to endure the longest journey imaginable? The periodic table of elements is the same across the universe, but the recipe used here feels alien, not because the elements are new, but because the chef seems to have separated them with a precision that nature simply does not possess. When we look up at the night sky and track the journey of this celestial wanderer, we are immediately confronted by a visual puzzle that seems to break the standard rules of how comets should behave. The first and perhaps most striking feature of this massive ghost is the phenomenon known to astronomers as the anti-tail. To the casual observer, this feature looks completely wrong. We are taught from a young age that a comet is like a cosmic windsock. The solar wind blows against it and the tail streams out behind the comet, pointing away from the sun. It makes intuitive sense, just like throat trailing behind a moving train. However, this object displays something that looks like a headlight. Instead of just a tail flowing backward, there is a distinct bright spike projecting forward, pointing directly toward the sun. It gives the unsettling impression that the comet is not just drifting but driving, illuminating its own path through the darkness of space. This creates a visual tension, making the object appear aggressive like a ship ploughing through the waves with a searchlight on its bow. Shutterstock. But this headlight is actually a grand illusion caused by geometry and gravity. It is a trick played by our perspective from Earth. As the comet travels, it does not just release fine gas, it also releases heavier, larger dust particles. While the light gas is easily blown backward by the solar wind, these heavier grains of dust are stubborn. They are too heavy to be pushed away easily. Instead, they are left behind, floating in the wake of the comet, settling into the flat disk of the comet's orbit. When Earth moves through a specific angle, we find ourselves looking perfectly horizontally across this disk of dust. We are seeing the trail of heavy debris from the side, and due to the angle, a portion of this trail visually overlaps with the front of the comet from our point of view. It is a ghost of the past appearing to lead the way into the future. Beyond this optical illusion lies a deeper, more physical mystery regarding the movement of the object. This is the strange stillness of its flight. In the chaotic environment of the inner solar system, a comet is usually a volatile, unstable thing. As the sun heats, the surface pockets of ice explode into steam. These jets of gas act exactly like the thrusters on a rocket ship. According to the basic laws of motion, for every action, there is an equal and opposite reaction. If a massive jet of gas shoots out from the northern side of a comet, the comet itself should be pushed toward the south. This is called non-gravitational acceleration, meaning the object moves in ways that cannot be explained by gravity alone. Yet this massive ghost defies that expectation in a way that is almost unnerving. It is clearly active. We can see the coma, the halo of gas and the dust. It is shouting into the void, venting gas and energy, and yet its orbit remains remarkably pure. It follows the smooth mathematical curve dictated by gravity with barely any deviation. It does not wobble. It does not drift off course. It is as if the creature is so heavy, so incredibly dense and massive, that its own violent outbursts are like a mosquito pushing against a tank. The jets fire the gas screams, but the mountain does not move. It creates a feeling of immense, unstoppable inertia. It is not a leaf blowing in the wind, it is a cannonball that has forgotten how to stop. This leads us to the true reality of the object hidden beneath the glowing green fog, the nucleus itself. To understand this object, one must strip away the beautiful wispy light of the coma and imagine what lies inside. It is a flying mountain. We are talking about a solid object with a diameter of approximately 5 kilometers. To visualize this, imagine ripping Mount Everest or a mid-sized city out of the ground, freezing it until it is harder than steel, and hurling it through the vacuum of space. The scale is terrifyingly large compared to the delicate appearance of the gas cloud surrounding it. If this object were to sit on the surface of the Earth, it would pierce the clouds. It is a jagged, irregular landscape of ancient ice and dark, carbon-rich rock. It is not a smooth snowball, it is a scarred survivor. The surface is likely blacker than coal, reflecting almost no light, which is why the glowing gas is the only reason we can see it at all. There is a profound contrast here that defines the nature of this massive ghost. To our eyes, looking through telescopes, it appears soft, ethereal and fragile, a smudge of light that looks like it could be blown away by a breath. But the reality is a beast of billions of tons, is a silent, lurching monster. The Ghost title is fitting not because it is dead, but because it is a heavy, invisible presence draped in a thin sheet of light. It carries a gravitational weight that demands respect. It is a flying island carrying the frozen history of the early solar system locked deep within a crust that has remained unchanged for 4 billion years. This 5-kilometer width explains the lack of orbital deviation. The mass is simply too great. The jets of gas that would send a smaller comet spinning wildly out of control are absorbed by the sheer bulk of this object. It is a testament to the power of momentum. While smaller comets dance and skip as they melt, this one marches. It lurches forward with a steady, silent determination, its path fixed by the gravity of the sun, ignoring its own internal explosions. When we visualize this object, we must hold two opposing ideas in our minds at once. First, the anti-tail, the illusion of light and speed, the searchlight pointing forward created by dust and geometry. Second, the mountain, the dark, cold, heavy reality of the nucleus that anchors the show. One is a trick of the light, the other is a planet-killer-sized rock. Together, they form an object that feels contradictory. It is bright yet dark, active yet steady, a cloud yet a stone. It travels through the darkness, not with the erratic energy of a panicked bird, but with the slow crushing confidence of a glacier, sliding down a valley. It is a massive ghost indeed, silent, heavy, and passing through our lives with a slow-motion majesty that belies the violence of the gas erupting from its surface. Imagine standing in the middle of a thick, ancient forest at midnight. It is pitch black. You cannot see the trees, but you can smell the pine and feel the damp earth beneath your boots. The most striking thing is not the darkness, but the silence. Is the forest empty? No. You know it is full of life. There are owls, wolves, insects, and perhaps other hikers. Yet everything is quiet. The animals do not howl or chirp because they know a simple rule: making noise reveals your location. In the dark, silence is safety. This is the core concept of the dark forest hypothesis, but we do not need to view it as a horror story. Instead, we can view it as a lesson in cosmic wisdom and caution. As we look through the lens of the 3E Atlas, we begin to understand why the universe might be so quiet. The Loeb scale, measuring the noise. To understand our place in this forest, we first need to measure how loud we are. In the scientific search for extraterrestrial life, we use something called the Loeb scale. Think of this as a ruler that measures the technological power of a civilization and how easily we could detect them from far away. The scale runs from 0 to 10. 0 represents a planet in its natural state. There is no technology, no radio waves, and no artificial light. It is biologically active like Earth 2,000 years ago, but it is silent to the rest of the universe. 1 to 3 is where we find early technological civilizations. This is where humanity is right now. We are somewhere around a 1. We have illuminated our cities with electric lights that can be seen from space. We have been leaking radio and television signals into the galaxy for about 100 years. To a powerful telescope, Earth looks like a small flickering candle in a dark room. We are not blindingly bright, but we are no longer invisible. 4 to 6 represents civilizations that have mastered their own star system. They might build giant structures to harvest energy from their sun. They do not just live on planets, they change the shape of their solar system. They are much brighter and easier to spot. 7 to 10 describes civilizations that are godlike. They can control the energy of entire galaxies. They might move stars around or travel between galaxies as easily as we travel between cities. Here is the troubling question. If the universe is billions of years old, there should be civilizations at level 7, 8, or 9. They should be blazing like lighthouses. But when we look up, we see nothing but natural stars. We see no grand machines, no moving suns, no artificial lights. We see only the Loeb scale at 0. Why? The philosophy of the quiet forest. The traditional dark forest theory suggests that civilizations stay quiet because they are afraid of being hunted. It paints a picture of a universe full of predators. However, let us look at this through a philosophical lens. It is not necessarily about fear, it is about maturity. When a child walks into a library, they might shout and run around. They want attention. But when an adult walks into a library, they are quiet. They understand the atmosphere. They respect the silence. Perhaps that the universe is not a hunting ground, but a place of deep, respectful caution. Advanced civilizations, those high on the Loeb scale, might realize that shouting into the void is unwise. They do not hide because they are cowards, they hide because they are prudent. They might have realized that resources are finite. Expanding endlessly and consuming galaxies makes you a target not just for weapons, but for competition. Therefore, the smartest move is to turn the lights off. They might use communication technologies that do not leak into space, such as directed lasers or neutrino beams, which act like whispered messages rather than broadcasted shouts. In this view, the silence of the universe is actually a sign of intelligence. It is a busy forest, but everyone is moving softly, respecting the dark and keeping their campfires small so as not to disturb the balance. The view from the three-eye atlas. If the three-eye atlas is an eye watching the cosmos, what has it seen during its long, lonely vigil? The three-eye atlas is not a human eye. It does not blink and it does not get tired. It stares at the same patches of sky for years. In that time, it has likely seen the ghosts of the universe. It sees stars that exploded millions of years ago, their light just reaching us now. It sees the cosmic dust swirling in the dark. But significantly, the three-eye atlas observes that the most powerful forces in the universe are often the most invisible. Black holes, for example, are the masters of the dark forest. They're incredibly powerful, yet they allow no light to escape. You can only find them if you look at how they affect the things around them. Perhaps advanced civilizations mimic black holes. They cloak themselves. From the perspective of the three-eye atlas, the universe looks like a vast ocean at night. Occasionally a fish jumps, creates a splash and then disappears. These splashes are the brief moments when a civilization makes a mistake and reveals itself as a burst of radio waves or a flash of energy. But mostly the ocean remains smooth. The atlas sees a history of silence. It learns that survival belongs to the quiet ones, not the loud ones. The fragility of Earth. This brings us back to us humanity. In this vast, silent forest, Earth is a very noisy, very naive child. We have been shouting hello to the universe for a century. We sent the Voyager probes carrying maps to our location. We blast high-power radar at asteroids. We light up the night side of our planet so brightly that it looks like a diamond. On the Loeb scale, we are trying to climb higher, trying to become louder and more visible. We assume that if anyone hears us, they will come to help us or teach us. We assume the strangers in the forest are friends. The philosophy of the dark forest suggests that this is a dangerous assumption. We are small, our planet is fragile. In the scale of the cosmos, Earth is nothing more than a single leaf in a forest that stretches forever. If the three-eye atlas could speak, it might tell us to lower our voices. It would remind us that we do not know what lives in the dark. Being quiet doesn't mean we stop exploring or stop doing science. It means we should be careful. It means we should listen more than we shout. We are currently standing around a campfire singing songs thinking we are alone. But just beyond the light of the fire, the forest goes on for millions of light years. It is filled with ancient things, wise things, and perhaps dangerous things. And they are all watching the one group that is foolish enough to make noise. The silence of the universe is not empty space. It is a heavy, meaningful silence. It is the silence of a hunter waiting or a sage thinking. As we continue our journey with the three-eye atlas, we must learn to respect that silence, for it is the only shield we have. Let us leave the blue skies of Earth behind and transport our minds across the vast ocean of space. We are travelling millions of kilometres away to a place that feels both alien and strangely familiar. We have arrived at the orbit of Mars. The first thing you notice here is the colour. It is not just red, it is a deep rusty ochre, the colour of dried blood and ancient iron. Below us, the planet spins slowly. It is a world of extremes. Huge dust storms can swallow the entire globe, turning the thin atmosphere into a hazy pink fog. It is a place of silence and biting cold. On the surface, the temperature drops far below freezing cold enough to turn carbon dioxide into dry ice. It is a graveyard of a planet beautiful but dead, where the wind whispers over rocks that have not moved in billions of years. But above this silent world, there is life, robotic life. Floating in the black void above the Martian atmosphere is always a veteran explorer. It is the Mars Reconnaissance Orbiter, often called MRO. This spacecraft has been our faithful scout for many years. It is a large machine powered by the sun, buzzing with electronics and heaters to keep it alive in the deep freeze of space. MRO has a very special tool on board a device that is the pride of planetary science. It is called HiRISE. Think of HiRISE not just as a camera, but as a telescope in reverse. Most telescopes look up at the stars. This one usually looks down at the ground. It is the most powerful camera we have ever sent to another planet. It is the sharpest eye of humanity. Its vision is so keen, so precise, that from 300 kilometers up in space it can see something as small as a dinner table on the surface of Mars. It has shown us avalanches of ice dust devils twisting across the sand and the lonely tracks of our rovers driving on the red dirt. However, on October the 3rd, HiRISE has a different mission. It receives a command from millions of kilometers away, sent by the team at NASA. The command is simple but risky. Stop looking down, look out. The spacecraft must rotate. It has to turn its back on the planet it studies to face the empty darkness. It is waiting for a visitor. The asteroid 24P25 is approaching. This is the moment of the Martian rendezvous. It is not a collision. It is a cosmic dance. In the vastness of the solar system, two tiny objects, a robot built by humans and a rock born from the dawn of time, are about to cross paths. They are moving at speeds of thousands of kilometers per hour faster than a rifle bullet. If the mathematics is wrong even by a tiny fraction, the camera will capture nothing but empty stars. The timing must be perfect. As we wait for the moment of capture, a question hangs in the minds of the scientists back on Earth. It is the same question that haunts everyone who looks up at the night sky. What will we see? This is where the imagination takes over. We have seen asteroids before. Usually they are lumpy, ugly things. They look like potatoes or jagged shards of coal. They are covered in craters battered by billions of years of history. We expect to see a rock. We expect to see a surface that is rough, dusty, and irregular. That is the natural order of things. But there is a tiny whispering hope in the back of our minds, the Arthur C. Clarke hope. What if the image comes back and the object is not rough? What if it is smooth? What if instead of a jagged rock, HiRISE captures a perfect geometric shape? A cylinder, a sphere, a rectangle with sharp 90-degree corners. If the camera reveals a rock, it is geology. It is an interesting piece of data about the formation of our solar system. It tells us about the chaotic past of our neighborhood. But if the camera reveals a shape that nature does not make, that is history. That is the moment everything changes. A perfect shape implies design. Design implies intelligence. And intelligence implies that we are not alone. The tension on October 3rd is not loud. It is not like a movie with explosions and dramatic music. It is a quiet, slow-burn thriller. Up there in orbit, there is no sound. The spacecraft turns silently using its reaction wheels. The huge camera lens, a cylinder of metal and glass, points toward a specific patch of darkness. The target, 2024 PT5, is currently just a shadow against the stars. It is small, perhaps only 10 meters wide. Spotting it is like trying to spot a fly buzzing around a street lamp from kilometers away. The computer on board counts down. The shutter does not click like a handheld camera, but the sensors activate. Light photons that have traveled from the sun hit the asteroid and bounced off enters the lens of HiRISE. The light hits the detectors. The image is frozen. Did we catch it? We do not know yet. Mars is currently light minutes away from Earth. This means that even moving at the speed of light, the signal takes a long time to travel back to us. The spacecraft stores the data on its hard drives. Then it must turn its antenna back toward Earth, aiming at the Deep Space Network, those giant radio dishes in California, Spain, and Australia. It begins to transmit. The data flows slowly across the emptiness. It is a stream of ones and zeros fighting against the background static of the universe. On Earth, in mission control rooms, screens flicker. The scientists sip cold coffee. They are not looking for a monster. They are looking for a few pixels of light. This is the beauty of the rendezvous. It is a meeting of two travelers in the night. One is a traveler of rock and metal wandering the solar system for eons without eyes or a mind. The other is a traveler of silicon and aluminum built by curious apes from a blue planet sent out specifically to witness the universe. For a brief window of time on October 3rd, they are neighbors. The camera stares, the rock passes by. The image that is forming on the screens will tell us the truth. It will strip away the mystery. We are about to see the face of our temporary moon. Will it be the familiar, comforting face of a grey cratered rock? Or will it be the shocking, smooth face of something else? The file downloads. The processing software begins to render the picture. The static clears. We lean in, holding our breath, ready to see what the sharpest eye in the solar system has found in the dark. The calendar turns to October 29th, marking the most critical moment in this celestial journey. This is the day of perihelion. In the language of astronomers, perihelion is simply the point in an orbit where an object comes closest to the star it is circling. For our traveller, this is not just a milestone, it is a trial by fire. After travelling for thousands of years through the freezing darkness of the outer solar system, the comet has finally arrived at the doorstep of the Sun. The environment here is violent and terrifyingly beautiful. If we could stand on the surface of the comet right now, the Sun would not look like the yellow coin we see from Earth. It would cover a massive portion of the sky, a raging ocean of plasma and magnetic fire. The temperature here soars to thousands of degrees. At this proximity, the comet is no longer gliding through empty space. It is tearing through the Sun's outer atmosphere known as the corona. This is a region of intense heat and radiation, where the solar wind blows not like a breeze, but like a hurricane of charged particles. It is here, at this precise moment of maximum danger, that the comet performs its great vanishing act. To an observer on Earth, this seems like a cruel irony. For weeks we have watched the comet get brighter and brighter, hoping for a spectacular show. Yet on the day it is most active, on the day it is releasing the most dust and gas, it completely disappears from our night sky. The Sun acts as a giant, blinding curtain. Because the comet is physically positioned on the far side of the Sun, or directly in line with it, the glare is overwhelming. The light of the Sun is millions of times brighter than the comet. Trying to see the comet next to the Sun today would be like trying to spot a tiny firefly flying next to a powerful stadium spotlight. Our eyes cannot handle the contrast, and most of our standard telescopes cannot point that close to the Sun without risking permanent damage to their sensitive lenses and mirrors. The main actor has walked onto the brightest part of the stage, and the stage lights have blinded the audience. However, there is more happening here than just a visual disappearance. In the invisible world of physics, the comet is receiving a massive gift of energy. This is a phenomenon known as the Oberth effect. It is one of the most fascinating mechanics of space travel, acting like a cosmic kick. To understand the Oberth effect, imagine a child on a playground swing. If you want the child to go higher, you do not push them when they are at the highest point of the swing where they have momentarily stopped. You push them at the very bottom of the arc, right when they are moving the fastest. A push at the bottom creates much more speed and height than a push at the top. Gravity works in a similar way. As the comet falls toward the Sun's massive gravity pulls it in, making it fall faster and faster. By the time it reaches perihelion on October the 29th, the comet is moving at its absolute top speed, hundreds of kilometers per second. This is the bottom of the swing. Because it is moving so fast, the energy of its motion changes. Any small change in velocity here translates into a huge change in its final energy. It is as if the Sun grabs the comet, spins it around and slingshots it back out into the deep solar system with incredible force. This gravitational assist is what allows comets to travel such vast distances, flinging them back out toward the edge of the solar system, not to return for another 80,000 years. But this speed comes with a price. The stress on the comet is unimaginable. It is not just fighting the heat, it is fighting the gravity itself. The Sun pulls on the front of the comet harder than it pulls on the back. This difference in pulling force, called tidal force, tries to stretch the comet apart. If the comet is a solid rock, it might survive, but if the comet is a rubble pile, a loose collection of ice and rocks held together only by weak gravity, the Sun will tear it to pieces. It will crumble into a stream of dust, destroying it completely before it can ever emerge from behind the curtain. This leads us to the silence of the unknown. As the comet passes perihelion and loops behind the Sun, we enter a period of information blindness. For the scientists and astronomers back on Earth, this is the most nerve-wracking time. We are effectively blind. We cannot send radio signals to a probe near the comet easily, because the Sun is a massive generator of radio noise. The static and interference from the Sun drown out everything else. It is like trying to hear a whisper while standing next to a jet engine. We lose clear data, we lose the visual feed. The comet enters a zone of silence. During these weeks, we are left with nothing but mathematics and hope. We know the path the comet should take. We know where it should appear if it survives. But we have no way of knowing if it has actually survived until it comes out the other side. This waiting game is agonizing. Every day that passes in silence is a day of speculation. Has the heat vaporized the ice that holds the comet together? Did the tidal forces shatter the nucleus? Or is the heart of the comet strong enough to withstand the fire? We are waiting for the magician to pull back the curtain. When the glare fades and the comet moves far enough away from the Sun to be seen again in the twilight sky, we will know the answer. We will either see a glorious bright comet with a long tail refreshed and energized by its encounter with the star, or we will see nothing but a fading cloud of dust, the ghost of a traveller that flew too close to the fire. Until then, we watch the data monitors. We check the solar observatories in space that use special disks to block out the sun's glare. We look for a tiny pixel of light emerging from the darkness of the shield. The show has reached its climax, but the audience must wait in the dark to see if the hero has survived the vanishing act. The earthly noise. While the object itself travelled through the absolute silence of the vacuum, tumbling end over end in the freezing dark, the planet it left behind was anything but quiet. On Earth, Oumuamua triggered a storm of noise that was loud, chaotic, and distinctly human. It's a profound irony that the most significant astronomical event of the century was defined not by the stillness of observation, but by the screaming matches of social media and the polite yet ruthless warfare of the academic world. This contrast highlights a fundamental truth about our species. We are uncomfortable with ambiguity. When faced with a silent mystery from the stars, we rush to fill the void with our own voices, our fears, and our desperate need for answers. The chaos of information. In the age of the 24-hour news cycle, Oumuamua was not just a scientific data point, it was content. The internet does not handle uncertainty well. Within days of the discovery, the narrative fractured into two extreme realities. On one side, there was the dull, safe reality presented by conservative science. A rock is just a rock, no matter how weirdly it behaves. On the other side lay the sensationalist realm of clickbait, where every tumble of the object was proof of an alien invasion fleet. Psychologically, this reveals our collective anxiety. We live in a world of instant gratification. If we have a question, we type it into a search bar and expect a result in 0.5 seconds. Oumuamua denied us that satisfaction. It appeared it baffled us, and it left before we could even take a clear picture. The frustration of not knowing drove the online frenzy. We projected our earthly chaos onto a visitor that was completely indifferent to our existence. The academic war, the cost of curiosity. At the center of this storm stood Avi Loeb, the chair of the astronomy department at Harvard University, and the conservative scientific establishment. This was not merely a disagreement about data, it was a battle for the soul of modern science. The scientific method relies on a principle often called the Sagan standard, which states that extraordinary claims require extraordinary evidence. The conservative faction held tight to this shield. To them, suggesting Oumuamua was artificial was a heresy because it broke the rule of nature first. They argued that we must exhaust every possible natural explanation, even the unlikely ones like hydrogen icebergs or dust bunnies, before we dare to whisper the word alien. Avi Loeb represented a different psychological approach to the vulnerability of curiosity. His argument was simple but dangerous to a reputation. What if we are missing the truth because we are too afraid to look foolish? Loeb argued that the scientific community was suffering from a stigma against extraterrestrial intelligence. By refusing to consider the artificial hypothesis seriously, scientists were acting like the church officials who refused to look through Galileo's telescope. This conflict highlights the intense pressure within the academic world. To suggest something so radical is to risk one's credibility. The noise from the academic community was a defense mechanism. By mocking the idea of a solar sail or a probe, mainstream science was protecting itself from the embarrassment of being wrong. It showed that even the most brilliant minds are subject to the very human fear of judgment. The anomalies between reality and fear. The debate focused on specific behaviors of the object, but the interpretation of these behaviors was heavily colored by human emotion. First, there was the non-gravitational acceleration. As Oumuamua moved away from the sun, it did not slow down as much as the laws of gravity said it should. It was being pushed. In nature, comets are pushed by jets of evaporating gas like a rocket thruster. But Oumuamua had no tail, no gas, and no dust. To the dreamer, this push was evidence of a light sail, a piece of technology harnessing the pressure of sunlight for propulsion. To the skeptic, it was simply invisible outgassing that we failed to detect. Then there was the tumbling. The object was not spinning smoothly. It was tumbling violently, causing its brightness to change by a factor of 10 every 7 to 8 hours. Some theories suggested this specific rotation rate, and the violent motion could be the result of a malfunction, like a broken probe drifting dead in the water. Analyzing these anomalies requires us to look at our own biases. Why is the broken alien probe theory so compelling to the public? Because it fits a narrative we understand. We understand machines. We understand car crashes. We understand broken technology. We tried to force the strange data into boxes that fit our earthly experiences. When scientists analysed the light curve, the way the brightness pulsed, they were looking for patterns, but the public was looking for a signal. We wanted the tumble to be a message or the acceleration to be a deliberate manoeuvre. We were looking for intention in the chaos, the psychology of the other. Ultimately, the noise surrounding Oumuamua brings us back to the most primal human emotion, loneliness. For decades, we have scanned the skies with radio telescopes listening for a beep, a hum, or a mathematical sequence. We have found nothing but the hiss of cosmic radiation. This is the Fermi paradox. If the universe is so old and so vast, where is everybody? The silence of the universe is terrifying to the human psyche. It implies that we might be the only conscious minds in a galaxy of dead stones. This creates a deep existential dread. When Oumuamua arrived, we projected all our hopes and fears onto it because we are desperate to end that loneliness. Even a terrifying alien civilization would be preferable to the alternative that we are completely alone. This is why the artificial theory is so sticky. It is not just about physics, it is about hope. Believing that Oumuamua was a piece of technology, even a piece of yonk, means that someone else is out there. It means we have neighbours. Conversely, the natural theory feels cold and empty. If it is just a rock, then the universe returns to being a graveyard of inanimate matter. The battle between these two viewpoints is the battle between our rational minds, which demand proof, and our hearts, which demand company. Conclusion. The object is gone now. It is currently moving beyond the orbit of Neptune, diving back into the interstellar dark, silent and unreachable. But the noise it left behind on Earth continues. The controversy was never really about the object. The rock didn't care what we thought. The controversy was about us. It held up a mirror to our anxieties, our rigid academic structures, our sensationalist media, and our deep aching desire to find someone else in the dark. Oumuamua proved that while our telescopes are pointed at the stars, our eyes are still very much focused on ourselves. The calendar on the wall flips to November 2025. The year is drawing to a close, but the eyes of the world are not looking at the holidays or the changing weather. Instead, they are fixed on the black screens of mission control centres and the starry sky above. The tension is thick like a heavy fog. We have spent the last few months analysing the strange data from the asteroid belt, but now we must shift our focus. We need to look at the tools we have out there in the deep dark. We are not blind. We have sentinels, mechanical watchers floating in the void. Far beyond the orbit of Mars, two silent travellers are cruising through the emptiness. These are the spacecraft known as JUICE and Europa Clipper. In the story of humanity's search for truth, these machines are the quiet observers. They were launched with the goal of studying the icy moons of Jupiter, looking for oceans hidden under miles of ice. But in late 2025, they play a different role. They are our first line of defense, not with weapons, but with awareness. Imagine them for a moment. They are millions of kilometers away from Earth. It is so cold out there that the temperature drops to hundreds of degrees below zero. There is no sound, only the silent hum of their internal computers. Europa Clipper is speeding toward its destination, its massive solar arrays stretching out like the wings of a giant bird to catch the faint light of the distant sun. JUICE the Explorer from Europe is following a similar lonely path. Right now, they are not yet at their final destination, but their sensors are wide open. If there is something moving through our solar system, a signal, a wave of energy, or an unknown object, these ships might feel it first. Scientists back on Earth are constantly pinging them, checking their magnetic field detectors and dust analyzers. We are asking them, do you feel anything different? Is the space around you calm or is it rippling? They are the watchers in the night, holding a flashlight in a dark forest, waiting to see if any eyes reflect the light back at us. While JUICE and Clipper are the travellers, we have another player already on the stage. This brings us to the dramatic story of Juno. The Juno spacecraft has been orbiting the giant planet Jupiter for years. It is a veteran. It has survived the harshest radiation environment in the solar system. Jupiter is not a gentle planet, it is a monster of radiation and magnetic storms. Juno has been dancing with this monster, diving close to the cloud tops and then swinging far away to recover. But in December 2025, we might face a difficult choice. If the data suggests that the anomaly or the source of the mystery is hiding near Jupiter, hiding within its massive gravity well, Juno's the only asset we have close enough to look. But to look closely might require a sacrifice. The engineers at NASA might have to command Juno to change its orbit to dive deeper into the danger zone than ever before. This maneuver would likely fry its electronics. The radiation would cook the computer brain of the spacecraft. This is the Juno scenario. It is the idea of sacrificing a loyal ship to gain one crucial piece of information. It is a somber thought. We imbue these machines with personality. We feel attached to them. But if sacrificing Juno means sending back one clear image or one distinct reading that solves the mystery before the ship dies, it is a price we must pay. It would be a hero's death for a machine burning up in the atmosphere of a gas giant to send one last message of truth to its creators. While the machines do their work, a heated debate explodes back on Earth. This is the question of MET messaging extraterrestrial intelligence. For decades, we have mostly been listening. We use massive radio dishes to listen for static or patterns. But now the question shifts. If we suspect something is out there, should we say hello? This is not a simple decision. It divides the scientific community and the public into two fearful camps. On one side, you have the optimists. They believe that if there is an intelligence out there, we should signal our presence. They want to beam high-powered radio waves or laser pulses toward the location of the anomaly. Their argument is that communication leads to understanding. They say, we are here, we are intelligent, and we are peaceful. On the other side, you have the realists, or perhaps the pessimists. They cite the dark forest theory. Imagine you're walking alone in a dark, dangerous jungle at night. You do not know what predators are hiding in the bushes. If you hear a twig snap, do you scream, "I am here"? No, you stay quiet, you hide. They argue that shouting into the cosmos when we do not know who's listening is dangerous. If the visitors are not friendly, sending a signal is like drawing a target on our own foreheads. In November and December 2025, this debate is no longer just for science fiction writers. It is discussed in the halls of the United Nations. It is debated in coffee shops and on social media. The decision is heavy. Once a signal is sent, it cannot be called back. It travels at the speed of light. We cannot undo it. The consensus that begins to form is one of caution. For now, we listen. We watch. We let Juice Clipper and Juno be our eyes, but we keep our mouths shut. We choose silence over the risk of shouting into the unknown. Finally, as the year ends, humanity begins to settle into a state of mental preparation. The panic that might have existed earlier in the year has turned into a strange kind of focus. We realize that whatever is happening, whether it is a first contact with aliens, a new breakdown of physics, or just a natural phenomenon, we never understood before we are about to learn a massive lesson. The preparation is not just about building bunkers or stocking food, it is a preparation of the mind. We are realizing how small we are. We are realizing that our borders and our petty wars on Earth are insignificant compared to the vastness of the theatre of space. If nothing happens, if the anomaly fades away, we learn that we are paranoid, but also that we are capable of coming together to watch the sky. If something does happen, we learn that we are not the centre of the universe. So as the final days of 2025 tick away, the world holds its breath. We trust in our mechanical watchers drifting in the cold void. We mourn the potential sacrifice of Juno. We keep our radio transmitters silent, but our receivers are turned up to maximum volume. We are ready to see what the universe has to show us. We are ready to turn the page to 2026, not with fear, but with open eyes. Close your eyes now. Let your eyelids become heavy, as if a soft, warm weight is resting upon them. There is nothing left for you to do. There is nowhere else you need to be. The journey we have taken together is coming to its natural end, settling softly like dust motes dancing in a beam of sunlight before finally coming to rest on the floor. Take a deep, slow breath. Inhale the quiet of the room around you. Hold it for a gentle moment, and now breathe out. Exhale all the tension, all the questions, and all the noise of the day. Let it all drift away like smoke in the wind. Think back just for a moment to the beginning of this story. Do you remember how it felt when we first looked up when the name, 3i Atlas, was just a whisper of something unknown? There was a feeling in the pit of your stomach. It was a small knot of fear. It is natural to fear what we do not understand. The darkness of space is vast, and when something new arrives, our first instinct is to worry. We asked ourselves, what is it? Why is it here? Is it a danger? But notice how that feeling has changed. Feel how your heart beats now. It is steady. It is slow. It is calm. Over the course of this journey that fear has transformed, it shifted first into curiosity, that spark of wanting to know more. You watched, you listened, you learned about orbits and ice, about light and gravity, and now that curiosity has softened into something even deeper acceptance. You have made peace with the unknown. You have realized that the universe is not here to threaten us, but simply to exist. It is a grand, silent stage, and we are the audience watching a magnificent play. The fear is gone, replaced by a quiet sense of wonder. You are safe. You are warm. You are simply a witness to history. Now in your mind's eye, look up one last time. Visualize the vast velvet blackness of space. It is deep and endless, a blanket that wraps around the entire world. There in the distance is our traveller, Three-Eye Atlas. It is no longer a mystery. It is a friend waving goodbye. See it as a faint shimmering point of light. It is moving away now. It has finished its dance near our sun. It is drifting back out into the deep ocean of the night. Maybe it is heading toward the frozen edges of our solar system. Maybe it is beginning a long, long loop that will bring it back in 1,000 years or maybe 10,000 years. Or perhaps it is leaving us forever destined to wander between the stars for eternity. It does not matter where it goes. What matters is that it was here. It came to visit, and now it leaves fading slowly into the shadows. It is silent. It is peaceful. It is just a piece of rock and ice floating on a river of gravity. Watch it get smaller and smaller, from a bright star to a dull glow, from a dull glow to a tiny speck. And finally it disappears into the great dark. It is gone. It is... Shift your focus now. Bring your mind back closer to home. Below you the Earth is still spinning. It turns slowly, steadily, just as it has for billions of years. Nothing has stopped that rhythm. The sun still rises in the east. The sun still sets in the west. The tides still roll in and out against the sand. The seasons still change, turning green leaves to gold and back again. Feel the stability of the ground beneath you, even if you are in a bed or a chair. You are anchored to this massive, beautiful blue planet. Gravity holds you in a gentle embrace, keeping you safe, keeping you grounded. The atmosphere above is like a thick protective quilt shielding us from the cold of the void. We are living in a special time. Tonight, as you lie here, realize that you are part of a rare moment in history. Years from now, people will read about the time the visitor came from the dark. They will look at pictures and study the data. But you were here. You lived through it. You felt the change from fear to peace. There is a profound beauty in not knowing everything. We often think we need to have all the answers. We want to know every number, every coordinate, every date. But there is magic in the mystery. It is okay that some questions remain unanswered. It is okay that the universe keeps some secrets for itself. That mystery is what makes life beautiful. It reminds us that there is always something more to discover. So cherish this feeling. Cherish the fact that you are a tiny conscious part of this massive universe capable of looking up and wondering. You are small, yes, but your abilities to dream is infinite. Now let your body sink deeper. Feel your toes relaxing. Let the relaxation spread up through your feet into your ankles. Let your legs become heavy and loose, sinking into the mattress. Let your hips relax. Let your back release any tension vertebra by vertebra, smoothing out like a calm sea. Relax your shoulders. Let them drop away from your ears. Let your arms feel heavy and limp at your sides. Unclench your hands. Let your fingers curl naturally. Relax your neck. Relax your jaw. Part your lips slightly. Smooth out your forehead. Let your eyes rest deeply in their sockets. The sky outside is quiet. The stars are shining their steady light millions of kilometers away. They are watching over you, silent guardians of the night. They do not judge. They do not rush. They simply burn with a gentle ancient light. Imagine yourself lifting gently off the ground, weightless. You are floating up higher and higher, but you are not cold. You are wrapped in the warmth of starlight. You are merging with the flow of the cosmos. You are no longer separate from the sky. You are part of it. You are made of the same stuff as the stars. The iron in your blood, the calcium in your bones, the carbon in your breath. It was all cooked in the hearts of ancient suns. When you look up, you are looking at your family. When you sleep, you are returning to the great rhythm of nature. Three-Eye Atlas is drifting in the silence. The earth is spinning in the silence, and you are resting in the silence. Everything is as it should be. The universe is unfolding exactly as it must. There is no need to worry about tomorrow. Tomorrow is a different world, right? Now there is only this moment, this breath, this darkness, this peace. Let the image of the traveller fade completely. Let the image of the earth fade. There is only a soft, comforting grey mist around you. It is the mist of sleep. It is inviting you in. Drift, float, dream. You are safe. You are loved by the universe. You are at peace. Good night. Sleep well within the flow of the stars.